Welcome to lesson 2.2, day 1, looking at the repeating zeros of a polynomial function. Actually, this is day 2. We're asked to state the number of real possible zeros and turning points and determine all of the zeros by factoring. In this one, this is a 4th degree polynomial. So there are up to 4 zeros and up to 3 turning points, as you saw in your exploration. To solve, we'll set it equal to 0 and factor. The greatest common factor is x squared. Factoring this, I have x plus 3 by x plus 2, multiplying to 6, adding to 5x. Setting each factor to 0, this one gives me x equals 0. Notice it has a second degree on it, so it has multiplicity 2. This one is x equals negative 3. This one is x equals negative 2. There are my 4 zeros, 1, 2, 3, 4. 2 that are distinct and one that has multiplicity of 2. In the second example, there is also x to the 4th, so there are up to 4 zeros and up to and minus 1, so 4 and minus 1, 3 turning points. So whatever the degree is, that will equal your maximum number of zeros, of real zeros. And whatever, if the degree equals n, then n minus 1 equals the number of turning points up to that number. So for this one, x squared will factor out yet again. So x squared minus 4x plus 4. This is x minus 2 by x minus 2. So I have x equals 0 with multiplicity 2 and x equals 2 with multiplicity 2. 2 4 factors of x, but this is repeated twice and this is repeated twice. They have multiplicity. Graph a polynomial function. We're supposed to do a graph of the polynomial function, or sketch a graph of the polynomial function by applying the leading terms test and finding the zeros and knowing how the multiplicity behaves at any repeated zero or graph, and then graph the function. If I do this, x squared is what's the leading term that's going to come out. 3x is going to come out of that, and x. When I multiply those, I have 3x to the 4th as my leading term. So my leading term is a positive lead coefficient and an even degree, which means it's going to function much like a parabola in terms of its end behavior. The zeros are x equals 0, x equals, I subtract 1 and divide by 3, negative 1/3. Here I add 1, x equals 2, but this has multiplicity of 2. Now we know from our exploration and from Algebra 2 that when it has even multiplicity, the graph will bounce at the x-axis. And that bounce is said to, that the graph is tangent to the x-axis. If you remember from geometry, tangent means that it does not intersect. It touches, but it doesn't cross over. So when I sketch my graph, I have to have a 0 at 0. I have to have a 0 at, let me space these out a little bit, negative 1/3. And I have to have a 0 at 2. The multiplicity of 2 is where it's supposed to bounce. And I know the ends are supposed to go up. That means that this one will come down and then come back up and intersect. And then it will come back down and bounce off the x-axis. Oh, and you can't see my graph. There we go. So I drew my ends up first after I had my 1, 2, 3 points plotted. Knew this one came down, then up, intersects the axis again, bounces back off. For our next problem, we have x, positive x cubed times 2x times x. Our leading term is going to be 2x to the 5th. So again, positive lead, this time positive lead coefficient, but odd degree, which means our ends are going to function like a line with a positive slope. Our zeros This one gives us x equals 0. Here I add 3 and divide by 2. X equals 3 halves, or 1.5. Here x equals negative 4 multiplicity of 3. We know from our exploration and from Algebra 2 that an odd multiplicity intersects, so I'm going to say crosses, the x-axis and twists. There's a twist there, so that one direction is concave and one direction is convex. So we'll take a look at that as we graph this. So I have negative 4. I have 3 halves, which is 1.5, and I have 0. I know that on this end it's going to shoot up, and it's going to come down, and it's supposed to, this one's just another intersection point. This one's supposed to be going down, so remember this is functioning like a line. But it's not going to be like a line, it's going to curve. So I've got my curve going this way. See how it's concave this way. When it crosses, it's going to switch. It's going to be concave this way. So concave this way right now and concave the other way. That indicates the little twist there. Then it comes up and comes down. I don't know how high it goes up or how low it goes down, but I know these are the x-intercepts, and I know there is a twist here. And just in case it's not clear, I'm going to label that. Here we can clearly see the bounce. Here we might not be able to see the twist, so I'm going to label that. In our last example, the leading term, here we've got x, positive x cubed, positive x. If that had been a negative, it would be negative x cubed, because negative to an odd power turns out negative. So it'll be 3x to the 5th. 1, 2, 3, 4. Oh, 6th, because this one was squared. So this is also positive lead coefficient, but an even degree, like our first one. This time we're going to have a twist for this odd multiplicity and a bounce for this even multiplicity. So we have x equals 0, x equals negative 2, and there will be a bounce, which we don't have to label, we'll be able to see on the graph, and x equals 1, where there will be a twist because of the multiplicity of 3. So I go to graph this, and I have to put on 0, 1, and negative 2 on my graph. We know the ends will both come up because it's an even degree and it's positive lead coefficient, so it's going to function like a parabola in terms of its end behavior opening up. But we know that at negative 2, it's going to bounce. So we're going to have this coming down, and it's going to bounce right off the axis, tangent to that. We know that at 1, there's going to be a twist. So if it's coming up like this, then on this side, so see how it's concave to the left? Now on this side, it's concave to the right. Then it comes down and comes back up. This is just a regular intersection point here at 0. So I just cross over the x-axis. This is a quick sketch of our graph. Just in case we can't see it, I'm going to label this twist. I don't need to label the bounce. Repeated zeros and polynomial functions. Highest degree multiplicity, we've already talked about this on the other side. 0 has odd multiplicity, then it crosses the x-axis, and the value of x changes signs at x equals c. F of x changes signs. We know that it crosses. If a 0 has even multiplicity, then the graph is tangent to the x-axis, and the value of f of x, the sign of it, does not change signs, so it will stay positive or negative or whatever sign it started out as. On to building polynomial or writing polynomial functions, which should be reviewed, but we're going to do just a couple quick examples. If x minus c appears more than once in factored form, then it is called a repeated zero. We're not quite there yet. If a zero has odd number of times, graphically the polynomial will cross the x-axis at that point, and it will do it at a twist. So right and twist. If it has even multiplicity, it will bounce at the x-axis. So if there's just one factor, it just intersects. But if there's an odd that's not 1, it will cross and twist. If it's even, it will bounce and be tangent to the x-axis. Now, ax minus b is a 0 if and only if x equals b over a. This is saying that if you have your factor, I could multiply by a and subtract b to get, if I have my answer for x, I could write this as a factor of the polynomial equation. So if these are all the zeros, one has multiplicity of 2, then I have x minus 1 times x minus 1 times x plus 4, because I'm going to add 4 to get it into the factor, times x minus 7. Now for you, you may want to write x equals 7 and then subtract to make sure you get the right sign. I'm going to do 2 sets at a time and then distribute among those. So this is x squared minus x minus x. So it's x squared minus 2x plus 1. My next one is x squared plus 4 plus 7 is plus 11x. Oh no, plus 4 minus 7 is minus 3x. Let's get that right. 4 times negative 7 is negative 28. So now I have to distribute these. I have a lot of students who prefer to do box method. If you need to do that, you can. If you like just doing regular distribution, you can just do regular distribution. So I'm going to give you an example of this right now with box method and with regular distribution. With regular distribution, I have x squared by x squared, negative 3x cubed, negative 28x squared. Next I have negative 2x cubed, positive 6x squared, positive 56x. Then I have positive x squared, negative 3x, and negative 28. I went through and distributed x squared to every term. Then I did negative 2x to every term, then 1 to x to every term, and now I can combine like terms, giving me x to the 4th minus 5x cubed, negative 28, and 6 is negative 22, and another positive 1 would be negative 21x squared. 56 minus 3 is going to give me positive 53x, and then I have negative minus 28. So there's my polynomial function built from those 4 zeros. It is a quartic equation. If you don't like this method, you can do box method. A lot of people like box method better. X squared minus 2x plus 1. What was our other one? X squared minus 3x minus 28. You'll get your products this way. This is x to the 4th minus 2x cubed plus x squared minus 3x cubed. Sometimes it's a little faster to do this because you just have to think about each box and then combine them at the end. But you can choose positive 56x and negative 28. So again, we're going to get the same things that I just got above. Right, here's negative 28, 53x, negative 21x, negative 5x, sorry, cubed, that was squared, here's cubed, and x to the 4th. Same thing we got up here, just another way to get it. So for the next example, here I have x equals 1/2. I will write this out because I'm going to multiply by 2, and then I'm going to subtract 1. So 2x minus 1 by x minus 3 by x plus 6. I'll do these two together first. I've got x squared minus 3 plus 6 is plus 3x minus 18. You can multiply this by 2x minus 1 by distributing the 2x to everything and then the negative 1 and combining like terms. Or you can do box method if you want. Here's 2x cubed, 6x, negative 36x. This should have been x squared. Here's negative x squared, negative 3x, and positive 18. And combining like terms, I have 2x cubed plus 5x squared minus 39x plus 18. There were 3 zeros. The polynomial is a 3rd degree polynomial cubic equation. Last example is what happens if we have it on the graph. We have to pay attention. Notice there is a bounce here. So that has even multiplicity at x equals -1. There are two factors. Here I have x equals 2 and x equals 3. So I'd have x plus 1 by x plus 1 by x minus 2 by x minus 3. And I would multiply these two out and these two out and then multiply them together. This next one, again, we have a point of tangent C. Now, it might have an even degree higher than 2. I'm going to assume 2, though, for the simplest one that I can come up with. This would be x equals -5 and x equals -5. Here's x equals -1. Notice it crosses 4 and there's a twist in the graph. So technically, I should have an odd number of x to the fourths, and then here I have x equals 7. So I'm going to have to do get a quadratic from that, a quadratic from that, a quadratic from that, and a singleton here. Multiply two of the quadratics, multiply it by the third quadratic, and multiply this one. So my factors would be x plus 5 by x plus 5 by x plus 1 by x minus 4 by x minus 4 by x minus 4 by x minus 7. And our last example, we have a singleton here at x equals -5. That's going to give us a factor of x plus 5. We have a singleton here at x equals, well, it kind of changes directions, but it doesn't do the little twisty thing necessarily. So this would be, we're going to pretend that it doesn't, x equals -3, so x plus 3. Here we have x equals 0, so just x. Here we have x equals 3. So x minus 3. And here we have x equals 5, so x minus 5. You could do this product and this product to get two quadratics, multiply them together, and distribute x into everything, and you would get your polynomial function. This concludes the video examples for lesson 2.2. Learning targets for here will be to be able to find the real zeros, to state the number of possible zeros and turning points, and to use your information and your knowledge of even versus odd multiplicity along with leading coefficient or leading terms test to be able to sketch a graph. And our very last concept of this, the learning target, was to be able to build a polynomial equation using the zeros that were given either in number form or in graph form. Have a great day.